a pretty simple idea. It did not take us all that long to think about it. Like it came together in like a couple of days where it's like, oh, why doesn't it work like this? Yeah, that works. Like, okay, let's do that. Right. Like it was pretty simple, but definitely the scale that Pyth operates at today just would not have been possible if we hadn't come up with this pull model.
It's fascinating to me just watching the underlying technical stacks kind of shift from these earlier networks being much lower throughput, have longer block times, longer finalities, to these much higher throughput ecosystems that have much lower latency. And when you do that, you also have to upgrade everything else in the tech stack to make it also high throughput and low latency like Oracle's. And I think we're going through that entire process. And then once you do that, what type of unique applications can leverage all those components? Jayant, thank you so much for coming on the podcast. Looking forward to it. I think what Douro Labs has been building with Pyth is super exciting. Exciting time for the company with the airdrop that you guys recently did. Just tremendous progress. And I think ultimately what Pyth enables is just really new, interesting applications. And so really excited to have you on, excited to dive into all of it.
Thank you so much for having me, Logan. I'm looking forward to the conversation.
Yeah, I would love to just get a quick pulse check on like how things are internally at Douro Labs. You recently did the airdrop, and I think anytime any company does an airdrop, there's lots of excitement, not only internally, but externally as well. If you could just give us a sneak peek behind the windows internally and how that is you're viewing it.
Yeah.
I'd love to hear it.
Yeah. No, for sure. I mean, people are excited about it. We did the airdrop. We listed the token about 2 weeks ago. And that's a big milestone, for any project, right? It's kind of like the beginning of decentralized governance and all these kinds of things. So, it's really exciting in that perspective. And it's obviously something that, the team has been working on for a long time, right? And so whenever you get one of those milestones, I think it's people are going to get jazzed up. And, I think things really went quite well. Like you've seen airdrops where there's a lot of, FUD on crypto Twitter or whatever. And like, seems like everything went really smoothly. So really couldn't be happier.
That is amazing. Yeah. The crypto Twitter is a funny place. I think sometimes it affects real life and sometimes it's a over amplification of really dumb things. So it's hard to parse that apart sometimes.
For sure. Yeah, I think it is. It's like sometimes there's like really smart takes on there, but like sometimes it's just like it's FUD. It's just like, random guy saying something and someone amplifying. So, yeah.
Yeah. Maybe before like diving into the tech stack of what Douro Labs has built with Pyth, can you share a little bit more about just like your background, how you got into the crypto industry, and how you actually ended up building one of the more interesting technologies within the crypto sphere?
Yeah, for sure. So, my background is I actually have a PhD in machine learning and natural language processing. So I used to work on kind of like dialogue models, I guess before they were cool. And so that's kind of my traditional background. And I've been working that for a number of years. I was at a startup. We got acquired by Microsoft, kind of did the whole thing. But I've always been interested in crypto. I've been interested in crypto since 2014 or so, when that's when I first got into it, because it's actually kind of a funny story. Like there was this Carnegie Mellon professor I was at Carnegie Mellon, I was doing my PhD, and there's this rumor that, he'd made a bunch of money in cryptocurrency. And like, we didn't really know what he did, but like people were interested, right? And, your grad students, like some extra beer money would be nice. So, we got interested. We started thinking like, oh, like what can we do in cryptocurrency? This is interesting. And so, I thought about it and I was like, what? I can do some like programmatic trading. So I sat down and I built a programmatic trading system for cryptocurrencies back in 2014. This was super early days. I mean, this is before Coinbase had an exchange, Like I remember when the Coinbase exchange launched and I was like, oh, cool. Like this is awesome. So it was pretty early days. It wasn't very competitive back then. So I did reasonably well. I ran that for a few years, shut it down around 2018 when like the pros started playing. But I've been interested in the space ever since. I've been following along, following the technology and things like that. And, I was really interested in like Ethereum, the promise of kind of building these applications that run on the blockchain. But, the whole time I was in it, right? Like it always felt like vaporware. I mean, people never really were, building these apps, right? And then so in 2020, someone showed me Compound, and I was like, oh, wait, this is a real application running on the blockchain that does a useful thing. And I was like, okay, like this is really interesting. Like now's the time to like get involved. And so I was kind of looking around for what to do. A friend of mine from college actually worked at Jump, and he just joined the crypto division. He was like, you got to come check this out. This is crazy. So I was interested. I threw my hat in the ring. I got a job. And, it was crazy. I mean, it's bull market, everyone's running around, right? Like everything's on fire. But I sat down, I started doing some research, kind of developing some of the mechanisms behind Pyth. And that kind of evolved to where I am today.
That's amazing. Maybe in terms of like framing the conversation a little bit, just in terms of what were some of the things either from Jump or either in trading that you learned from like high frequency standpoint that didn't really map too well to blockchains and ultimately maybe created the like genesis or the birth for Pyth?
Yeah. So, one of the things that there's actually a couple different things that as someone who's kind of deeply versed in financial markets that didn't really make sense when we looked at oracles and how they were designed, back in the day. And a couple of those things are, first of all, that financial market data is really valuable. So the big exchanges make billions of dollars a year on market data. And all the hedge funds and things like that are basically paying subscription fees to these exchanges, right? And so if you looked at how oracles were built kind of back in the day, they kind of assumed that all data was free. It's like, look, we're going to build a system that goes and it scrapes the web and it gets the price from, 3 different websites and it posts that on the blockchain. And, I get why people build a system like that. From an engineering perspective, it is kind of elegant and like, it's a simple solution to the problem. But, we looked at that and we realized like, this just isn't going to work. I mean, this data is valuable. Like you need to have a way to actually compensate the owners of that data, for providing it. So that was kind of one of the key insights that, led to the design of Pyth. Another insight was just that, real-time data is important. I mean, you need data to be fast and low latency. Like high frequency, low latency is really important in trading and basically any financial application. And oracles on the blockchain were updating at like a frequency of 1 hour. And we knew that it just wouldn't be possible to build really interesting financial applications if your prices are delayed by an hour. So, another really key emphasis for Pyth was basically making sure that we had, high frequency, low latency prices that we knew would be required, right? I mean, like part of this was just we wanted to do something that would be good for the ecosystem. And we knew that like the ecosystem wouldn't be able to develop these cool applications without that kind of data quality.
Yeah, it is remarkable how valuable data has actually become, whether it's in AI or on the blockchain. I think people used to sell their data for a couple cents, and now they're a little bit more protective about it. And I think people, and perhaps the Pyth team, realized that very early on, especially kind of being on the market side and doing high frequency trading. That data is extremely valuable and kind of needs to make sure that it's compensated correctly for that data.
Yeah, it's totally true. And like, this is why we kind of built Pyth with the sort of first party data model where, all the people who own the data are actually the people who publish the data to Pyth. So, they're directly connected to Pyth. They're providing the data. They own it. So they're allowed to do that. And then like, the Pyth mechanisms are supposed to reward them for doing so, right? So there's actually a sort of an economic incentive to doing it, right? As opposed to it just being like free.
Yeah. In terms of kind of Pyth's unique angle in this compared to other industry practices, can you maybe dive a little bit deeper into how Pyth decided to partner with these publishers versus kind of the legacy model of how people were bringing data?
Yeah, I mean, so as I said, we knew that we'd have to basically compensate the owners of the data, right? We knew that would be important in any sort of, long-term Oracle project success, right? And so, we were at Jump, and basically we just started having some conversations. And this is not my wheelhouse. I'm the technical guy. We have great salespeople who do a lot of these conversations, so I can't tell you exactly how they went. But they reached out to some other financial firms, some other trading firms, and a lot of them were actually interested in doing this. And So, we got a few on board, and it's kind of snowballed from there. Um, what I can say about this is that there's a couple different things that I know, at least, that those kinds of traditional finance firms and stuff have found interesting about the process, which is that there's actually a lot of curiosity, I think, in that space about crypto, and like people are kind of looking for ways to get involved. And but it can be hard for them, right? There are regulatory barriers, things like that. So Pyth was actually a very easy way for them to kind of like get their foot in the door and build some experience on the team with crypto, setting up a wallet, custody, like all these kinds of things, which are they're new, right? So I think that was actually an angle that a lot of people found compelling. Um, the other one is that there are actually financial firms who have data who are not currently monetizing it. Like a lot of trading firms have very accurate pricing for, the price of assets because they trade them, multiple times a second. So, they know what the price is. But they're currently not monetizing that data. And so Pyth actually gives them a way to monetize that, which is interesting for them, right? It's like found money.
Yeah, both of those are fascinating. I think, to your point, blockchain has either been scary or there's not been a good financial reason to actually dip your toes in the water, even though you're intellectually curious. And by allowing that solution of one, to incentivize parties to be more willing to share that data, and two, get a small window into what the next iteration of finance technology looks like, it's a compelling pitch.
Yeah. It's been pretty successful. We've had like pretty dramatic growth in data providers. We have a lot of big name traditional finance firms on board. We have a lot of the big crypto exchanges, trading firms on board as well. So we've been adding like a couple publishers a month, something like that, for the whole time we've been around. So it's been a pretty compelling pitch, I guess. Yeah.
Yeah, very impressive nonetheless. Maybe shifting more from like the marketing side to the technical side, that latter aspect that you mentioned of making sure that the data is fresh, real time, as low latency as possible. Would love to kind of parse apart that and how the Douro Labs team created that within the Pyth network.
Yeah. So that's a great question. And we had this goal basically of having low latency, high frequency prices. And at the time, what we thought was, okay, what we're going to do is we're going to build Pyth on basically the fastest blockchain that we can find, because the fastest blockchain is going to give you the best latency and frequency, right? And so that was Solana. So we built Pyth on Solana. We launched our initial version on Solana. Quickly grew to basically kind of have the entire Solana market, most of the Solana market. I don't remember the stat offhand, but pretty much all the major protocols on Solana use Pyth today. And so that was kind of our first big success as a project. But we knew that, even when we were starting the project, that it wouldn't be enough to just kind of be on one blockchain, right? Because, the state of the world, I mean, especially if you look at it today, the state of the world is there's so many different blockchains out there. There's so many different technologies. It's really not clear how this is going to play out, right? Like, are we going to live on EVM rollups, or are we going to live on these monolithic blockchains like Solana, or maybe like Aptos? Like, who knows, right? So, and it could be the case that there are different choices that make sense for different applications, right? Like maybe it's really nice to have Move if you're building X and you want to do something else for Y. So you could see this playing out a bunch of different ways. And like as an Oracle, we thought the important thing is we want the data to be available for developers wherever they're building, right? It doesn't make sense to just build it on Solana and only serve the Solana developers. You want everyone to have the data. So so we kind of had this goal even from the beginning of kind of expanding out to other blockchains. And so we recently, maybe not recently, maybe about a year ago, kind of took the step to do that, where we designed this kind of new PythNet blockchain with this pull architecture that's kind of allowed us to be really, really scalable to lots of chains. So Pyth is on 40 something blockchains today. It's a number that's growing all the time, and powering apps, across them. So it's been pretty great.
Yeah, it is rather remarkable. I mean, supporting 40 different architectures is no easy feat. And one thing that you mentioned was really that kind of caught my eye was that pull model. From the technical standpoint, I think Pyth was the first to do so, or one of the early kind of pioneers of this model. Can you compare kind of the pull model to what was happening kind of traditionally in these Oracle architectures, and why the pull model is much better?
Yeah. So, maybe to take you back in time, like we kind of made this decision to create this pull model about a year ago. And the reason that we did it was because, we had this desire to kind of go to other blockchains. And we thought about the economics. So the way other oracles worked at the time is, they're what we call push oracles now, which is they would basically have, some off-chain service that periodically updates the on-chain price, right? So it sends a transaction, pays some gas, updates the on-chain price. And we were actually thinking about doing that. We're like, okay, great. We do that on Solana. Let's do that everywhere else. And but we started thinking about it deeply, and we realized that the economics of this just like did not make sense. Because when you're running a push oracle, every single time you update the price, you pay some gas fee to do that, right? And this actually
just for the
is,
normies that like don't understand what push means, that's just publishing the transaction to the chain regardless of anybody requesting that information, correct?
Yeah, that's right. That's right. Basically, the Oracle is, running a service which like every 10 minutes is going to submit a transaction, right? You submit a transaction, you pay gas, right? Something like that. And so, okay, so the problem with this was like we realized like, look, what do people want from an Oracle? They want lots of price feeds, right? They want lots of different assets so that whatever asset they want is one of them, right? They want lots of updates per second. They want it to be updated high frequency, right? They want they want it on lots of blockchains, right? I mean, they don't really necessarily want it on lots of blockchains, but they want it on their blockchain for sure, right? And so, all of these product attributes, like if you think about operating the push oracle, like every single one of those costs you money, right? I mean, every time you list a price feed, like suddenly you're paying more to operate this thing, all the time, right? If you want to do more updates per second, like suddenly you're paying more. And you want to do more chains, you're paying more, right? So if you actually look at the offerings of kind of these push oracles, they're very fragmented, right? It's like, look, we've got 100 feeds on Ethereum, but we've got 8 feeds on Avalanche, something like that, right? And like the reason for that is fundamentally that, every single one of these feeds is an operating cost. And it's a hard decision for them to like say yes and like add more stuff. And so, we didn't want to be in that position, right? We didn't want to be out there and having to make these like kind of product compromises in order to like basically make the economics make sense. So we thought about that a bit, and we kind of said, look, what if we could come up with a model that takes this like operating cost and basically converts it into a fixed cost, right? So that there's no, added cost to like, add a new feed or increase the updates per second or whatever. And so that's kind of where the pull model came from. And the way that the pull model works is basically Pyth has a whole system, which we can get into, which, basically takes prices from data providers, combines them, creates this like signed price payload, right? Which basically says, this is the Pyth price at this time. Here's some signatures that you can verify to validate that it's authentic. And those prices are basically, they're just streaming all the time, but they're not on the blockchain. They're coming out of a decentralized system and they're just hanging around, right? There's a peer-to-peer network. You can listen to it. You can grab them. And then what we do is we say, look, if you want to use the Pyth price, there's a contract on your favorite blockchain. What that contract does is you can give it one of these payloads. It'll verify the signatures. And, if everything checks out, it'll say, okay, this is an official Pyth price at this time, and it'll save it on the chain. And then you can basically read that price, right? So the way that we envision people using this is basically, we call it the pull model, which is whenever someone actually needs a price, they go and retrieve one of these payloads. They put it on the blockchain themselves. It's a permissionless operation. Anyone can do it. They put it on the blockchain themselves, and then they use it, right? And so that way, basically, the Oracle is not the one paying the gas. It's actually distributed to a bunch of different users who are, they're submitting transactions anyway. I mean, they're already paying gas. It's not like we're, making the cost of this crazy more expensive or anything. And it basically distributes the cost to the users of the thing. And it also makes sure that nobody's paying for updates that nobody needs, right? So like we can list assets or price feeds, right, today. And like, if nobody uses it, it's fine. It's not like anyone's paying money for that, right? Whereas with the push oracle, every single one is, paying for these push updates.
It is, it seems rather simplistic on the surface, but the unlock was rather massive in terms of cost, the savings, the distributions, the engineering complexity between all the changes. It's rather remarkable how some simple things, the pull versus push, can unlock.
Yeah, I mean, it's totally true. I mean, I'm not going to sit here and be like, yeah, this is some crazy complicated idea. I mean, it's a pretty simple idea. It did not take us all that long to think about it. Like it came together in like a couple of days where it's like, oh, why doesn't it work like this? Yeah, that works. Like, okay, let's do that. Right. Like it was pretty simple, but definitely the scale that Pyth operates at today just would not have been possible if we hadn't come up with this pull model.
Yeah, it's a lot of data that you can be publishing to the chain for sure. In terms of maybe diving a little bit deeper, can we touch upon like PythNet and some of the underlying architectures that you guys decided to do there?
Yeah, so this is kind of getting into basically, we have the pull model, and this is kind of getting into like, how are those price payloads, that are being streamed in this peer-to-peer network, how are those constructed? And, we wanted to do this in a decentralized way, right? We're building a decentralized protocol. We wanted to make sure that, everything that goes into the system is decentralized. That's important not just from like a principles perspective, but it's also important from like a reliability perspective and a security perspective, right? Because you don't want a single entity to be able to basically manipulate the price or anything like that, right? So the decentralization is actually core to the kind of whole value prop of the product. And so we want to do it in a decentralized way. And what we came up with was basically, so, we were already running Pyth on Solana. And so our initial proposal was something like, well, why don't we just keep running it on Solana, and then we'll, bridge the prices from there to other blockchains. But we realized that this wasn't going to work for a couple reasons. One is just because there's this operating cost thing, right? Where like, again, we now start paying for more feeds, and that could be a problem. The other one is just, Solana has been super, super successful, like with a bunch of communities that are like not Pyth. And that's great. That's great for Solana. But the chain does get congested at times. And like, that's not great from the perspective of like, hey, you're on Ethereum, you want to have a reliable price update from Pyth, but Solana is congested because someone's minting like this hugely popular NFT. So tough, right? Like, so that's not great. So we just wanted to kind of come up with a system that really got us to that fixed cost thing instead of having still some variable costs. And also just, go ahead.
Do you think, it was interesting when I've done a couple podcasts with Anatoly now, and he was like, one of our biggest kind of learnings was how the blockchain actually was used in production. And in hindsight, it probably seems obvious, similar to like the pull model versus the push model, but like doing localized fees. And that was not enabled initially within the Solana blockchain, and eventually later added. And I think now like the other high throughput blockchains like Sui and Aptos do similar things. Would that kind of alleviated some of those early issues that Pyth was experiencing?
Yeah, that's a really good point. And I think it's worth it to kind of highlight the timeline on this, right? Which is like, if you remember last summer, this is a long time ago, right? But like last summer was kind of when we were making these decisions. And it was also when these issues were like the most prominent on Solana. So that definitely factors into your decision making at the time, right? I think Solana actually, really props to them. I think they really have a really solid engineering team who's like sat down and solved a lot of these issues, and like things are much, much smoother now. We still have the push Oracle on Solana today, and we know, right? We see all the congestion and stuff as part of that, and it really has worked a lot better since they kind of rolled out the local fee markets and stuff.
Yeah, I'm curious. It definitely makes sense from an engineering point of view in building out PythNet, just for the fact of supporting as many blockchains as possible, having that like single network be able to do the distribution, then having it on like one other blockchain.
Yeah. So, right. So just to get back into it, basically, we're like, okay, well, what we're going to do is we're going to set up our own blockchain. It's called PythNet. It's a fork of Solana. So it runs the same code base, but it's, totally independent network, right? And the data providers basically run the validators of the network, right? So they are, they're already contributing data. They can just run another piece of software, right? And basically, we run, all of the logic on that network that like takes data provider prices, combines them into sort of the Pyth aggregate price. That all happens on PythNet. And then what we do from PythNet is we basically bridge the prices to other chains using Wormhole. So, Wormhole is this like decentralized message passing protocol where it allows you to basically communicate between blockchains. And the way it works is they have a network of, I think, 19 guardians where they basically monitor the state of the chains, and they basically sign messages that attest that the state is whatever. And so basically we have those guardians, and they're basically signing messages saying like, these are the Pyth prices at every point in time, right? Taking those aggregates and creating these signed price payloads. And then, that plugs into the pull model, right? So users can basically grab those payloads, put them permissionlessly on target chains, and use them.
So maybe just to kind of re-articulate from my knowledge, I mean, ultimately two components of Pyth Network. One is kind of that pull model that we've been kind of discussing in length, where someone can request a price that is then that price is already on PythNet from a number of data providers that the Pyth network works with, that is signed and kind of can be verified. And then for whatever blockchain you're requesting on, that then moves through Wormhole, kind of a generic messaging processing bridge that will deliver the price to the end developer that requested the update.
Yep.
Interesting. Very interesting. I guess like in terms of like this tech stack, like has there been any surprises? I mean, in working this, seeing how it actually works in production, I think when I talk with a lot of like either layer 1 or layer 2 founders, they're often surprised by the workloads that they'll see in production versus what they thought they would have seen. Any parts in your tech stack that or the Pyth tech stack that has kind of surprised you?
I don't know. I mean, I think we kind of knew going in, we'd been running the Oracle and Solana. The PythNet Oracle is very, very similar code base wise. So like we kind of knew how that would look. Running some of the Solana validators it's a little bit of an operational challenge. They're pretty complicated to run, and like they need a lot of bandwidth and stuff. So there's definitely some work that, people have had to put in to kind of make that work smoothly. But I think things have gone pretty. Yeah, I don't know. I don't think I've seen a ton of surprises there. We don't have like, other people coming in and computing like on PythNet, right? It's just us. So I think that part has been fine. I mean, I think like the flip side of this though is like you got to ask like what are the users of Pyth, right? And like I think there's probably been some surprises there.
And maybe diving into that, what type of applications predominantly use Pyth, and I guess any predictions on new companies continuing to onboard with Pyth?
Yeah. So I think the big, been a couple surprises there. I think, one of the big surprises for me has been just like how popular perps are, right? So, I think this year has kind of been like the year of perps, right? Like there are perps exchanges just everywhere now. And like that didn't used to be the case, right? I mean, you had a couple last year, but it's really the trend. And, I think that was surprising. And I think it's actually interesting because I think, a lot of those perps exchanges actually use Pyth. And I think Pyth has kind of just made it a lot easier to build that kind of system, right? Because if you go back in time, people were kind of rolling their own oracles to get that. If you're a perps exchange, you need a really high frequency price update, right? A high frequency, low latency, because you're using it to mark all these positions. And so if you go back in time, people would have to basically build their own oracle. And like, it's actually pretty hard to build a high frequency, low latency oracle, right? So it's just like the technical lift required to launch a perps exchange was just way bigger then. And like now that you have better oracles like Pyth, you can see the trend of like people launching these things, right? I'm not saying it's easy now, but it's certainly easier.
Yeah, I think it's fascinating to me just watching the underlying technical stacks kind of shift from these earlier networks being much lower throughput, have longer block times, longer finalities, to these much higher throughput ecosystems that have much lower latency. And when you do that, you also have to upgrade everything else in the tech stack to make it also high throughput and low latency like oracles. And I think we're going through that entire process. And then once you do that, what type of unique applications can leverage all those components? And I think the analogy that I kind of use is going from dial-up to broadband and then fiber optics. And you can build new types of applications that you couldn't build on a dial-up type internet. And blockchains are, interesting enough, I feel like are going through a similar transition.
Yeah, I totally hear you on that. I actually love taking these sort of like early computing type metaphors to blockchains because I think they're quite applicable, and I think there's a lot of lessons you can learn there. Like even even like things where it's like, hey, someone had this idea in the 90s and it was a total failure in the 90s because like nobody was connected to the internet. but like, it was obvious. I mean, it's like the kind of thing that seems like a good idea. Pets.com, let's buy pet food on the internet. Seems like a great idea, right? And it's like, actually, it is a great idea. You just have to wait 20 years and call it Chewy, and it works, right? So like, I think there's a lot of that's going to happen here too, where like as the technology improves, like the applications that people built version 1 of in 2015, where it didn't make sense, like suddenly makes sense, right?
100%. Any favorite analogies that you have that you could share?
Yeah, I mean, one of the things that I've been thinking a lot about is sort of like, how is compute going to work in the future in the blockchain, right? Because, I said this before, but like we have this very fragmented situation right now where you have all these different blockchains, these different runtimes, and it it seems to me like well, it seems to me like the vision of maybe some folks initially when they're building blockchains is like, look, we're going to have one blockchain, everything is going to run on the one blockchain, and that's fine. And like you look at that and it's like, look, the blockchain is basically a single computer, right? So it's like there's not going to be a single computer for the entire world. Like there's just not enough. There's no way to make that computer big enough so that everybody has their fair share on the thing, right? So I think about it like those kinds of blockchains are basically like mainframes, right? It's like a shared computing environment that everybody sits down and works on, and then you kind of reach this stage where it's like, hey, like now all of a sudden it doesn't fit on this one mainframe. Like, what are we going to do? Right. So now we're kind of in this phase where it's like we're creating all these different chains. Like it's kind of more like the PC era, right? Where it's like you get your own chain for your own application. That's actually more like, there's all these roll up as a service kind of things right now, right? Where you get your own app chain. Like that's very much like the PC kind of era of things, right? So I think that's kind of an interesting trend. I think there's probably some broader lessons you can tease apart there, which I haven't, from like, how this is going to evolve in the future. Cause like, it didn't end at PCs, right? I mean, we went to cloud, there's distributed systems. I don't know what that looks like in crypto. I don't know if we need that. Seems complicated. Yeah.
That was going to be my next question. If kind of like the modular roll up landscape or application specific chain is like the PC era, do we go back to a few not central, but kind of 5 key players in terms of these big cloud providers, or 5 big VMs that people kind of agree upon and are predominantly used within these ecosystems?
Yeah. I think the VMs probably do consolidate because like there's a really strong network effect to the APIs of the virtual machine, right? Like I mean I see this all the time because like it's like, look, EVM, right, just by virtue of being the first, I think has a lot of backing behind it. There's a lot of people who built tools for it and things like that just like every new VM has to build, and it's like sometimes it's stuff that you don't even think about but is actually really important. Like for example, like you want a multi-sig, you want to have a multi-sig on your network, right? Like, well, someone has to build that if you have a new VM, right? Whereas on EVM, it's already built. Or like software libraries for just doing kind of common things that contract developers want to do. Like you have that in EVM. So I think that the network effect around some of these blockchain runtimes is very strong. It's kind of like the same as like, right now, how many operating systems do people really use, right? It's like Windows, Linux, Mac, right? And like, you don't really run serious software on a Mac. I mean, it's like a PC, but it's not like, you're running servers with Mac OS on it, right? So there's like really 2. And, there were definitely more competitors back in the day, right? It's just the network effects are really strong. So I think the VM, like the runtime environments, I think consolidate a bit. In terms of like, how many instances of those runtimes are there? I mean, I don't know. My expectation is that there's going to be a lot because like, the history of computing is basically that like people just want more of it, right? And like it scales both vertically and horizontally. It's like, look, we have this one network and it does 100 transactions. Now it does 200 transactions per second. Great. But I want 5,000. So I'm going to spin up 20, right? Like,
yeah, I totally agree there. I think the human desire is really, you always want more. You're always going to kind of need more bandwidth to propagate that data. You're always going to need more compute or more cores. I'm personally kind of biased towards the architecture designs that lean into that philosophy of just like scaling bandwidth and scaling compute, just because to your point, I don't know if there will ever be if you give an engineer more resources, I think they'll figure out a way to utilize them.
100%. And like people will say, oh, it's cheap enough now, so I can deploy my new application. And then like you start seeing new apps or whatever, right? I mean, there's a name for this, right? It's called Jevons paradox. It happens with like roads and things like that, right? So it's just, yeah, it's just the way of the world.
Yeah, it is fascinating. I guess in terms of just where you see not the blockchain landscape going forward, but more so just like Pyth Network and things that you're excited about at Douro Labs, are there any kind of not behind the scenes, but what future insights would you like to see or future product requests given to the network?
Yeah. I'll tell you a bit about like what's kind of going on now or what's sort of top of mind, which is I got two things. I mean, there's a lot of stuff happening, right? There's a lot of new blockchains, things like that. But two major things I think are, one is decentralized governance, right? So with the token launch and everything a couple weeks ago, we also launched decentralized governance. So token holders basically control the protocol now, and that's fine from a technical perspective. They control the protocol, but there's a whole social layer to that like people need to decide on. And like those people aren't me. I mean, it's the community of token holders, but figuring out how that sort of social governance process is going to work, I think is really important. And, at Douro Labs, we've gone through governance processes on a number of other protocols where it's like, hey, integrate Pyth and like, you talk to the stakeholders and things like that. And, we've gone through effective processes, we've gone through ineffective processes, right? So I think getting this right is like pretty important for, the health of the network as a whole. And so that's definitely something where, we have some thoughts about, how it should work, right? We have to like go talk to other stakeholders and kind of come up with some consensus there. But that's definitely something that's top of mind for us to work on. We've got another thing that's kind of happening, kind of interesting thing is Pyth is launching a random number product. So this is live in testnet. This is not a secret, but it's live in testnet on a couple networks right now. But this is kind of a new area for us. Random numbers is like pretty much the most common thing that people ask for when they're talking to Pyth, like the most common thing we don't support. So it's kind of cool to like finally be able to scratch that itch. And we have kind of a different take on random numbers than other protocols that have come before us. So, it'll be interesting to see how that plays out.
I would love to dive into that a bit further because I actually just recorded a podcast with Avery, who is the CTO of Aptos, and they're going to be working on some random numbers as well built into the protocol. So I this is the kind of a couple times that I'm hearing about it now, and love to dive deeper into why are random numbers exciting? Why are people now focusing engineering and efforts to making this happen?
Yeah, it's interesting. I mean, I think random numbers have been used on the blockchain for a number of applications already, right? I mean, people really want them for like NFT mints. You want to decide, the attributes that each NFT gets, or like you want to do like some sort of raffle or something like that, or games, right? Games are a big one for these kind of random numbers. So there's a bunch of different applications that want the random numbers. I think in terms of like, people have built solutions for this also, right? We're certainly not the first people to try to solve this problem. And there's like a lot of different technical approaches to doing random numbers on the blockchain. Maybe just to say a word about this actually, which might not be obvious, is like, if you're a computer scientist and you're listening to this and you're not familiar with blockchain, you might say like, why is it hard to generate a random number? I mean, like, on your computer, you just type rand or whatever and you get a number. It's like, fine. But the thing about the blockchain is that the state of the system is deterministic, right? So basically if you just ran the computation on the blockchain, everybody would be able to know what the random number is before it was generated. And like for things like an NFT mint, like you don't want people sitting there and trying to game it where they're like, okay, look, the number is going to be 7 and that's a good attribute. So quick, send a transaction, right? Like you want it to be unpredictable. So that's kind of the reason why it actually requires, some engineering work and it's not just some trivial thing. Now, yeah, I mean, I don't know why maybe now in particular is a time that people are paying attention to it. I mean, I do think that the high throughput trains have create an opportunity for like games and things like that to come on the blockchain. And I think that's the place where like you'll see serious usage of random numbers, right? Things like NFT mints are sort of one-offs, so it's not like maybe it's not the most compelling thing to serve. So that's interesting.
Yeah, the gaming aspect, it kind of to your point on like random loot or making sure that it's actually truly random and not someone able to gamify the underlying technology or to gain an unfair advantage, or even one thing that blockchains have been kind of popular for is gambling. If gambling people ultimately want to use randomness, that is very important.
Yeah, and I think one of the things that's actually interesting here is you can have like provably fair random numbers, right? So one of the properties of the protocol that Pyth is developing here is that the user can, as long as the user is honest and they participate in the protocol, like following the rules, they can guarantee that the result is random. Like they don't need to trust the protocol, they don't need to trust anybody on the other side. It's like all they have to do is behave honestly, and they know the result is random, right? So that's a really cool property. I mean, like that's something where like if you go to the casino and you push the button on the slot machine, I mean, maybe it tells you your odds of winning are 1%, but like, hey, you don't really know, right? Whereas like in this case, you can actually know for sure.
That is very true. I think it's one of the exciting things about the blockchain is kind of the provableness of it. You don't have to trust per se. You can also verify.
Yeah, for sure. And the transparency, I think, is very, very powerful. Actually, another maybe thing on transparency is like for Pyth, for example, right? We have this blockchain PythNet where all the data providers are aggregating their prices, and like this is fully transparent. I mean, it's a Solana network, and so like you can actually view the state of the system like using a Solana Explorer. So like you can actually go and like see all the prices that people are contributing, and you can see like exactly how Pyth works, really, right? So like I think that's a really cool property of the system that like I don't know, maybe is discounted, right? Or like it's certainly different from like Web 2 where it's like totally opaque.
100%. In terms of kind of where you see or where you kind of see the industry going for like the next year, I think it's been, unfortunately or fortunately, the industry is very cyclical. We've had a lot of ups and downs with bull markets, with bear markets, with large players ultimately taking a painful death. Is there anything that you're either learning lessons or things that you're trying to avoid, things that you've taken away from like the past couple of years?
Man, I gotta say, the biggest lesson for me is, leverage is dangerous. Like I knew that, but like, man, it's really dangerous. And also people will take a lot more of it than you expect. That part really surprised me the last time around. So yeah, I mean, that's maybe not a lesson for developers, but the thing I'll say is like, we've been in this little bear market. Things are feeling a little better right now. I think just, some of the Pyth folks were at Dev Connect and like they were pretty bullish over there. It seems like people are pretty amped up, but it seems to me like people are still building software and like doing the work, and like that's great. And I don't know. I'm happy they're doing that. I'm happy they'll probably do more of that in the bull market, and just try to keep your head down, and like focus on building, and like don't get too worried about the token prices, right?
Yeah, token prices are hard not to look at. They often bring people in. They can be distracting. A lot of shining new objects within not only crypto but within tech. I think for people that or engineers specifically that are interested in the industry and want to make a jump similar to you from like AI or any other field that are interested in blockchain technology from the engineering point of view, is there any advice that you could give those individuals to kind of dip their toes in the water?
Yeah, for sure. I mean, I would say, first of all, if you're interested, you should do it. Like this has been by far the most fun job I have had. Like crypto is it's a great space to work in. It's like tremendously collaborative, because like it really is it really is an ecosystem, and there's a lot of different, companies and people who are working on different things, and you have a lot of opportunities to interact, not just within your organization, but outside. And like that part's been really, really cool. It's all open source development. So like you can actually write code with people who work somewhere else. And it's like, it's really cool. Like it's really a fun job. I would highly recommend it. In terms of like, what to do, like, I guess like the thing I'd say here is like, this is like a meme last cycle, right? Like it's early, and like it is actually still early, like there aren't that many people who know what they're doing in the blockchain space. It's a relatively new field. So like, I wouldn't be intimidated by like saying like, I want to do blockchain, but I don't know anything. Like, you know what, just jump in, go write some contracts. Like pick a blockchain. I don't care. Pick whatever blockchain you want. Like go deploy an application, right? Like you'll pick up the basics pretty quickly, and like you can become, pretty knowledgeable like in a year or two, right? I mean, like you can basically reach kind of the edge of like maybe application developers on the field, right, in a pretty short period of time. And like that's really not true in other areas, So I think it's a great time to get involved, like while it's early. You have an opportunity to make a name for yourself. So we definitely encourage you to just jump in and do it.
I couldn't echo that more. I think when I got involved in 2017, I kind of felt like I was late, but I really felt early again when kind of 2020 and DeFi summer was going on, just because I started to actually play around with SQL queries on doing analytics and started being like, all right, how many active addresses are actually in these blockchains? And it's very few. And to your point, I mean, you can become an expert in the field relatively quickly if you kind of focus on the correct things and put in the work. It is complicated, but if you're interested and want to learn more, you can definitely make a name for yourself.
Yeah, absolutely. And like, I think it's always good to be just like in a nascent and growing space. If you move into a space that's like older, has more of a history to it. First of all, there's just a lot of ramp up time to like learn to kind of get to the edges. And then secondly, like there's already a lot of people who are like, well-known experts. And it's like, it's just harder to break into those ranks, whereas like if you join something that's early and growing, like that's sort of whatever, you're sort of riding a bigger wave, right? And like you kind of always want to be doing that.
I couldn't agree more. In terms maybe wrapping up, are there anything that you feel like we missed in the podcast or did not cover from like a technical side, a community side, any last like tidbits that we missed?
Man, that's an open-ended question. Let's see. I mean, I can't think of anything offhand. So yeah.
Okay. Yeah. Framing it another way, if people were to take a kind of like one or two like main points from our conversation or this conversation, what are the biggest things that you feel like people should come away with, either from Douro Labs or PythNet, and what you guys are building there?
Yeah. I think we're building a really interesting kind of new take on oracles, right? We're really committed to some of the, kind of crypto principles of decentralization and things like that, which I think, in the oracle space are maybe, let's say, not respected as much as you would hope. But like, we really are trying to build a decentralized oracle with, sustainable economics for all the parties involved, and like, have this work, high frequency, low latency, all that stuff. I think, one thing that I would like to, I guess maybe this is a thing that people forget a lot, which is like, I think, on crypto Twitter, people always go and they're like, Pyth, that's a Solana Oracle. But like Pyth is really a lot bigger than that these days, like actually the majority of the applications that use Pyth are not on Solana. And, we're on 40 blockchains. Like it's a very different world than it might've been a year ago. Like if that's when, you last heard about Pyth. So, definitely would encourage like developers, especially come check it out. We're available on Discord, Telegram. Shoot us a note if you have questions about integrating. But it's I guess I think it's a good oracle. Like check it out.
Check it out. Perfect. Well, we'll end it there. Thank you so much, Jayant, for coming on the podcast. Finally, excited that we made it through. Got to record this one, and excited for the public to listen to it.
Yeah, thanks a lot for having me, Logan.
Thank you.